third part is understanding probability. Now, entire statistics, all the assumptions is based on certain probabilities. So we will look into some very basic concepts of probability, and whatever is useful according for our biostats masterclass. So we'll just have a look at it. Now, probability of an event can be described as a spectrum from 0 to 1. I mean, what is the probability that an event will happen? The minimum value of a probability is 0, the maximum is 1. So 0 probability means you are certain that the event will never happen. 1 probability means you are certain that the event will happen, 100% certain that the event will happen. You cannot have a negative probability. This is one of the most important points you need to remember. There is no concept of negative probability. So the value of probability will be from 0 to 1. You cannot have a probability more than 100% also. So you cannot have a probability of an event more than 1. So probability of an event is, marked by small p. Then happens probability of an event not happening. That is the marked by small q. So q is nothing 1 minus p. Let's see an example. Suppose probability of a smoker dying of lung cancer is 0.1. So there's a 10% chance. 0.1 is nothing but 10%. So there's a 10% chance that a smoker will die of lung cancer. So probability of a smoker not dying of lung cancer is q, and that q is 1 minus 0.2, that is 0.8. So hope you understand the basic concept of probability. Now there are two rules on probability. One is the addition rule and multiplication rule. Now, addition rule applies when you have to calculate the probability of either of the two mutually exclusive independent events. Now, I'd like to take some time to explain it. Either of the two mutually exclusive independent. Now, two words I would like to focus on. Either. So, you're talking about, so addition rule will be applicable only when you are talking or using this term either this or either that of two mutually exclusive independent event. Now, exclusive independent event is those independents do not overlap each other, and happening of one event does not affect happening of the other event. I'll give you an example as we move forward. Now, let's say if you toss a coin, head comes. Next time you are tossing a coin, it is either head will come or tail will come. It does not depend upon whether the first observation was head or tail. So the second time, again the probability of either head or tail is 50-50%. So it becomes independent event. So the first observation of head or tail does not affect the second observation. So that kind of event is mutually exclusive and independent event. I'll give you another example. Suppose you have a pack of cards. The first card you pick is a ace, A. Now, the second card if you pick, the probability will change because the number of A's in that card is fixed. So then it is exclusive event, but it is not independent event. The second event is actually affected by the probability of the first event. Now I know it's a little confusing. Let me show you an example and you will understand. So addition rule of probability is shown by P A union B is equals to PA plus PB, which means probability of either A or B happening is equal to probability of A happening plus probability of B happening. If you see an example, probability of smoker having lung cancer, that is PA is 0.1. Probability of smoker having prostate cancer, PB is 0.2. So probability that a smoker will have either lung cancer or prostate cancer is 0.1 plus 0.2 is 0.3. Now here I made a very not so good assumption. I have assumed that a smoker can have only lung cancer or prostate cancer, but never both. So, which is a wrong assumption, but for the simplicity I have assumed it. Let's see another example. Probability of going to office by car is 0.4. Probability of going to office on bike is 0.3. So probability of going to office by car or bike is 0.4 plus 0.3 is equal to 0.7. So this is the addition rule of probability, where you are talking about either this event happening or that event happening. The second rule is rule of multiplication. In this, we talk about two mutually exclusive independent happening, and the word used it both. In the last slide we saw we use addition rule when the word uses either or, but here the word uses both. So both the event happening together. Again, the criteria is two mutually exclusive independent. Let me give you an example. Probability of A under intersection B is equal to probability of A into probability of B. Let's say probability of a smoker having lung cancer is 0.1. Probability of a smoker having prostate cancer is 0.2. So probability of that a smoker will have both lung cancer and prostate cancer is 0.1 into 0.2 is equal to 0.02. Now again we have assumed that if a person is having lung cancer and prostate cancer, it's not dependent on each other. Let's see another example. Probability of going to office by car is 0.4. Probability of going to office on bike is 0.3. So probability of going to office by car and bike is 0.4 into 0.3 is equal to 0.21. It's okay? There's something wrong. I mean, actually the probability of going to office by car and bike both together will be 0. So why are we getting 0.01? Remember, we have assumed that both are mutually exclusively independent event, which means the happening of one event does not influence the happening of the second event. But in this case, if the probability of going to office by car is 0.4 and going to office by bike is 0.3, but once you go to office by car, the probability of going to office by bike becomes 0. So they can never be mutually independent event. The happening of one event actually affects the happening of other event. So that is why this this example is wrong. So always remember this concept of mutually exclusive event, mutually independent event. Right? Mutually exclusive event is when there is no concept of both happening together. Independent is the probability of one event does not affect the probability of other event.